These are the worked out solutions to the 10.3 problems. In this problem we have an 80 centimeter chord that is 9 centimeters away from the center, so this length is 9. And since it's 9 centimeters from the center, it's implied it's a perpendicular distance. So this segment would actually be a radius or part of a diameter. And when it is perpendicular, or diameter is perpendicular to a chord, it also bisects it. So each of these lengths is going to be 40. If we draw on this segment, it's going to be a radius. And since it's a right triangle, we'd use Pythagorean theorem. That length is 41. It is a Pythagorean triple. The circumference is 2 times pi times the radius of 41, so we have an exact circumference of 82 pi, and that is approximately 257.61 centimeters. Here's problem number 2, and when you draw in diagonal AC, it intersects the circle at point E, and the length of AE is 9. If we were to draw in this other diagonal, those are perpendicular to each other, and we also have that these two small segments are congruent to each other because the diagonals of a parallelogram bisect each other. So we have this segment that is a perpendicular bisector of another chord, and when that's the case, that means that this segment must go through the center of the circle. So the center of the circle is in there somewhere. We don't know exactly where, and it's probably not at that intersection point. Since the length of AE is given to be 9, that means the diameter is 9, so the radius is equal to 4.5. So we can label that length as 4.5. Now if we draw in another segment, it's one of those well-placed segments. It's also a radius of the circle, and we're going to focus on this triangle at the bottom. That triangle has, first of all, is isosceles. This length is 4.5. Since the radius of a circle can't change, then this length is also going to be 4.5. And originally this angle and the corner angle DAB was 60 degrees. When we drew in the diagonal of the rhombus, it bisects the angle. So each of these little angles, specifically this one at the bottom, angle EAB, is 30 degrees. This is an isosceles triangle, so this angle is also 30 degrees. We're going to draw in this segment, which is perpendicular. And when you draw an altitude of an isosceles triangle, it also is a median and perpendicular bisector. It's going to be everything for us. So we have those two triangles which are congruent to each other. It's a 30, 60, 90 triangle. The hypotenuse is 4.5. So the short leg then is going to be half of that, or 2.25. And then from short leg to long leg, we multiply by root 3. So that is that length. If we continue with that, this length is also going to be 2.25 root 3, because once again, these two triangles would be congruent to each other, and so these corresponding legs are congruent, which means that the length of AB is going to be 4.5 root 3, and that's one side of the rhombus. There are 4 sides to the rhombus, so if we multiply that by 4, we get an entire perimeter of 18 root 3 units.